Hello, so in today's class we will begin the third module, which is on the principle of inclusion and exclusion. So in today's class we will first look at the simplest version of principle of inclusion and exclusion, and we will see a few examples. So നമ്മൾ ഈ മോഡ്യൂളിൽ മെയിനായിട്ട് ഒന്ന് basic principle of inclusion and exclusion കാണുന്നുണ്ട്. Then we will introduce what is called the generalized principle of inclusion and exclusion. So we will see different problems where the principle of inclusion and exclusion can be applied. So that is what we will be doing in the third module. So initially when we started the course, there we have seen the addition principle. Okay, so the addition principle states that so if A and B are finite sets such that so if they are disjoint, so A intersection B, if it is equal to phi, then the addition principle states that the cardinality of A union B will be equal to cardinality of A plus cardinality of B. So this is the addition principle. So if you have finite sets such that they have an empty intersection, so if A intersection B is equal to phi, then cardinality of A union B is given by cardinality of A plus cardinality of B. And now this is the addition principle. Now we will look at the case when A intersection B is not equal to phi. So if A intersection B is not equal to phi, then we know that in that case cardinality of A union B എന്ന് പറയുന്നത് that will be equal to, so they will have a non-empty intersection, so A union B, so that will be A, cardinality of A plus cardinality of B minus cardinality of A intersection B. So A union B, cardinality of A union B will be cardinality of A plus cardinality of B minus cardinality of A intersection B. So the value of A union B is said to be given by including cardinality of A and cardinality of B. So we have the inclusion of cardinality of A and cardinality of B, and cardinality of A intersection B is excluded from this. So this will give the value of cardinality of A union B. So the inclusion of cardinality of A and cardinality of B and the exclusion of cardinality of A intersection B will give the value of cardinality of A union B. So this is the most simplest form of the principle of inclusion and exclusion, and this can be extended to any number of sets. So നമുക്ക് മൂന്ന് സെറ്റ് വരുന്ന കേസ് എടുക്കാം, A union B union C, or you can look at A1 union A2 union etc. A n in general. So this is the principle of inclusion and exclusion. So this is the simplest form of the principle of inclusion and exclusion. And now using, so we have seen cardinality of A union B, so that is cardinality of A plus cardinality of B minus cardinality of A intersection B. Now let us look at what is the formula for cardinality of A union B union C. So we will use this result for doing that. So this is cardinality of A union B union C. So that is cardinality of A union B plus cardinality of C minus cardinality of A union B intersection C. So this is cardinality of A plus cardinality of B minus cardinality of A intersection B plus cardinality of C minus now this can be written as cardinality of A intersection C union B intersection C എന്ന് എഴുതാൻ പറ്റില്ല. ഇനി again this is in the form of two sets, so again apply this result. So you can write it as cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus this will be cardinality of A intersection C plus cardinality of B intersection C minus cardinality of A intersection C intersection B intersection C. So this is equal to cardinality of A plus cardinality of B plus cardinality of C minus cardinality of A intersection B minus cardinality of A intersection C minus cardinality of B intersection C. Now this can be written as plus cardinality of, so നമുക്ക് എല്ലാ ഓപ്പറേഷനും intersection ആണ് വരുന്നത്. So this can be written as A intersection B intersection C. Okay. So therefore this is the required value of cardinality of A union B union C. Cardinality of A union B union C is, so these three are included and this has to be excluded. So that is the value for cardinality of A union B union C. And if you extend it to more number of sets, so this is what you are going to get. So for any Q finite sets A1, A2, etc. AQ, where Q is greater than or equal to 2. So cardinality of A1 union, A2 union, etc. AQ, that will be equal to, so first you will have summation I equal to 1 to Q cardinality of AI's, then minus summation. So next you will have I less than J cardinality of AI intersection AJ, then plus you will have I less than J less than K. So cardinality of AI intersection AJ intersection AK. So next term minus varum. Okay, continuing that way, the last term will be minus 1 raised to Q plus 1 cardinality of, so the last one will be A1 intersection A2 intersection etc. AQ. So this is the principle of inclusion and exclusion when you have Q finite sets. So let us see few examples using the principle of inclusion and exclusion. So the first problem is, so let S equal to the set 1, 2, 3 etc. 500. Then find the number of integers in S which are divisible by 2, 3 or 5. So we need to define 3 sets. So let us define the sets to be as the set. So let's define as B2, B3 and B5. So B2 is the integers in S which are divisible by 2, and B3 is the integers in S which are divisible by 3, and B5 is the integers which are divisible by 5. And so we need to actually find the cardinality of B2 union B3 union B5. So let us look at the solution. So for each k belongs to n, let Bk be the set of all x belongs to S such that x is divisible by k. So by Bk we mean that is a set of all x belongs to S such that x is divisible by k. So we have the sets B2, B3 and B5. So we need to find the cardinality of B2 union B3 union B5. So by B2 you mean that is a set of all x belongs to S such that x is divisible by k. So let us first look at the cardinality of B2. Okay. So cardinality of B2 will be, so when you take 500 by 2, that will be equal to 250. So the number of divisors will be equal to, so that will be given by integer function of 500 by 2. So here it will be equal to 250. Now cardinality of B3 will be, so when you look at 500 by 3, so 500 by 3 will be equal to, so 166.66. So therefore the number of divisors will be actually 166. So that is the integer function of 500 by 3. So that is 166 varum. Then B5 will be equal to the integer function of 500 by 5 varum. So that is equal to 100. And next you need to find ഇനി intersections ആണ് കണ്ടുപിടിക്കേണ്ടത്. B2 intersection B3, then B2 intersection B5 and B3 intersection B5. So let us first look at B2 intersection B3. So that is the set of all x belongs to x such that it is divisible by both 2 and 3. അപ്പോൾ അതെന്ന് പറയുന്നത് cardinality of B6 ആയിരിക്കും. So set of all x which are divisible by both 2 and 3 must be divisible by 6. So it is cardinality of B6. So that is integer function of 500 by 6. So let us look at the value of 500 by 6. So that will be 83.33. So the integer part is 83. Again we look at B2 intersection B5. So that will be cardinality of B10. So that is 500 by 10 varum. So you will get 50. Then next is B3 intersection B5. So that is cardinality of B15. So let us look at 500 divided by 15. So that is equal to 33.33. So the value is going to be 33. And next we want B2 intersection B3 intersection B5. So that is cardinality of, so this will be B30. It must be divisible by 2, 3 and 5. But it must be divisible by 30. So you will get 500 by 30. So that is equal to integer function of 16.667. So that will be equal to 16. So we have got the cardinalities of B2, B3, B5, then the intersections, 2 taken at a time and all the 3. So now by principle of inclusion and exclusion, this is how we write the principle of inclusion and exclusion in short. So by principle of inclusion and exclusion, cardinality of B2 union B3 union B5 will be equal to, so let us look at the value. So that will be 250 plus 166 plus 100 minus, then we have 83, 50, 33, and the last one was 16. Oh. So the value is going to be equal to 366. So there are 366 integers which are divisible by 2, 3 or 5. And the next problem is let A, B and C be finite sets, then show that cardinality of A complement intersection B is equal to B minus A intersection B. So let us consider the sets A and B. Then A complement intersection B will be, so that will be this portion. Now let me start with B. So B can be written as A complement intersection B union. So this portion is A intersection B, and A complement intersection B intersection A intersection B, as you can see from the figure, that is an empty set. So therefore cardinality of B by the basic addition principle, so cardinality of B will be equal to cardinality of A complement intersection B union A intersection B. So that will be equal to A complement intersection B plus A intersection B. So hence we will get the required result. So cardinality of A complement intersection B will be equal to cardinality of B minus cardinality of A intersection B. And the next problem is a group of 102 students took examinations in Chinese, English and mathematics. Among them, 92 passed Chinese, 75 English and 63 mathematics, and at most 65 passed Chinese and English, and at most 54 Chinese and mathematics, and at most 48 English and mathematics. Then we need to find the largest possible number of students that could have passed all the three subjects. So let C, E and M denote the set of students who took solution. So let us denote the sets by C, E and M. Denote the set of students who took Chinese, English and mathematics respectively. This is who passed. Okay. And students who passed Chinese, English and mathematics respectively will be C, E and M. So you are given cardinality of C is 92, cardinality of E is 75 and cardinality of M is 63. So cardinality of C is equal to 92, cardinality of E is 75 and cardinality of M is equal to 63. Now at most 65 passed Chinese and English. So cardinality of C intersection E will be less than or equal to 65, and cardinality of C intersection M is less than or equal to 54, and cardinality of E intersection M is less than or equal to 54. Now by definition C union E union M is equal to cardinality of C plus cardinality of E plus cardinality of M minus cardinality of C intersection E plus C intersection M plus E intersection M plus cardinality of C intersection E intersection M. Now we need to find the largest possible value of C intersection E intersection M. So that will be equal to cardinality of C union E union M minus cardinality of C minus cardinality of E minus cardinality of M plus C intersection E varum plus cardinality of C intersection M plus cardinality of E intersection M. So now cardinality of C union E union M. So this will be less than or equal to 102 because this is because you know the total number of students who took the examination is 102. So the number of students who passed, the largest number can be 102. So this will be less than or equal to 102 minus now. So 65 minus 92 minus 75 minus 63 Then this will be plus 65 minus plus 54 plus, okay, here it is 48, last one is 48. Okay, so plus 48 to them, so the value is going to be equal to 39. So the largest possible number of students who passed all the three subjects will be 39.